Hi, I'm Gareth Spence, and welcome to another episode of Tech Talk. I'm currently at Small Cells World Summit talking to Clive Wright from ADVA's Oscilloquartz synchronization team about the importance of timing in 5G networks. Clive, can you tell me why this show is so important to Oscilloquartz?
Well, for us, small cells mean many things to different people. But the one key thing is that the radios all require very accurate timing to be working together. And coming here allows us to learn all the different technologies, all the way from the vendors, the large operators, and out to even the small private networks that are coming in the future.
Why does timing matter so much for small cells?
Well, timing has always been important, but generally it's always been what we call FDD in the marketplace. Now with 5G, we start to use TDD frequencies, and as we move towards TDD frequencies, the timing requirements become tighter and more important within the whole networks.
And why is timing more critical for 5G TDD?
Well, when we had FDD, Gareth, it was a little bit different because there was very large guard bands, and we didn't need every single network to run at the same accuracy. So now everything across the whole country has to be timed to a certain UTC level, otherwise they will interfere, and actually rather than occasionally having to make another call or turn around and say, I'll have to call you back, in this occasion you will start to get complete dead areas where networks will interfere with each other and will turn each other off completely.
Okay, and following that pattern along, what is the worst case scenario for those failures?
The worst case scenario is you could black out a whole area of 5G mobile connectivity and stop anyone using their mobile phone if you were bleeding all over the other operators' frequencies.
Walking around the show, there's a lot of conversation here about ePRTC. Can you explain what that is?
Well, one thing the operators look at when they're putting this together is getting to this 1.5 microsecond level. But they start to look at it just in normal operation. Most of that is done through GNSS, which is the satellite systems, the GPS, etc., that we get the timing from. Now, that is a vulnerable situation, so if that disappeared, we would have to make sure we maintained that even if we didn't have access to all of those satellite signals. So by adding in a backup of what we call an enhanced primary reference time clock, ePRTC, that allows us to maintain time even if the whole network is down for the GPS for up to 60 days. We can now maintain 70 nanoseconds of time accuracy from the core of the network.
And do your cesium clocks play a key role in that?
Yes. So we have now developed optical cesium, which is an optically pumped cesium clock. And by doing that, that allows us to get to the next level of accuracy that allows us to get up to that 60 days of 70 nanosecond holdover, along with the operation of our grandmasters, which have the ePRTC algorithm within it.
And how do you control that accuracy throughout a country or even the world?
Well, that's an interesting thing. Governments are now taking this very seriously. In America, they talk of it as APNT, or Assured Position, Navigation and Timing. Of course, we focus on the timing side of things within our business. And the governments now recognize there's a very large risk with just relying on GNSS only. So a lot of governments already are actually looking at having a backup timing supplied from the national metrology laboratories that can go into the core sites. And we're already seeing that happening in some key countries in the Nordics. And also, all of the regulators are now looking at how they assure timing is going to be there, even if we don't have the airwaves providing the timing. So all the regulators are now cleverly trying to find different ways to ensure that timing is available across the whole networks, and also ensuring that every operator and even the private 5G operators start to use the same time, which is all related back to UTC.
And given the current climate out there, it seems that this is a key thing. Having this backup is really critical.
It is. Of course, it's very important the network can carry the time at that stage, so there will be occasions where you can't have that backup. But if you can't have that backup, you need to be aware that you will need to turn your radio off so that you don't interfere with other people. So you have to take that risk. But having the backup is very critical, and making sure your network is designed with very careful layer 2 and layer 1 products to get the timing out there from the backup facilities.
Fantastic. Clive, thanks for talking to me today.
Absolute pleasure, Gareth.